G'day guys, welcome to the stream. Alright, let's see what we can do. So what we're trying to do today is we're going to enter a LEGO ideas competition. Okay, so I woke up this morning and I saw this competition that was posted on LEGO ideas. So it says that you have 33 days to submit an entry for the LEGO Mindstorms Robot Inventor set. So what we got to do is we got to build or design a sixth robot. So if you haven't seen the new LEGO Mindstorms set, there are 5 robots, and it looks like they want to crowdsource this 6th one, which is pretty interesting, I think. So if this is the first time you've seen my streams, my name is Gary. I am a robotics teacher in Sydney, Australia. So we are live streaming on YouTube and Facebook tonight. And yeah, we're going to see if we can design a bit of a prototype of a robot that we can maybe work on over the next few days or a few weeks, and hopefully submit it into LEGO Ideas. So just looking at these parameters again. So we need to have a description of what our model does, which is great. Key functions and features. You can see all the robots in Mindstorms look really spectacular. They're all very big builds. There's no really simple builds. So you have to be the original content creator, yeah. This is important. Entries must be new creations and not previously posted online or submitted to any other contest. So that's a big one, because I've got lots of ideas that I've already built. I can't submit them because they have to be new creations, not previously posted online. Fair enough. Use Lego pieces. Take a bunch of pictures. This is the judging criteria. Gotta make sure it's cool and original. Alright. So if you have a LEGO robotics kit at home, maybe you can join this competition as well, and we can see if we can win ourselves some more Mindstorms kits. So I guess what I really want to design is a self-balancing robot, because a self-balancing robot is just really cool. It's inherently cool, just functionally, and really interesting to program as well. And it's something that I am really interested in. So if you've seen my webpage, this is my website. So this is my self-balancing motorcycle, which is really good. I think we can try to make this using the new Mindstorms kit, or also, but today what I want to do is just demonstrate how to build this one. This simple balancer. So it's like a Segway where it balances on 2 wheels, and then you can't push it, and it stays upright. But we'll just change this design a little bit so that we meet that LEGO criteria. We want it to be slightly less stable than original, because the less stable it is, the more impressive it is when you try to balance it, right? If it's too stable when it's sitting down, then it's not really interesting. So yeah, so that is what I'm thinking. So let's have a look at our let's have a look at our gear here. So if you type in a message on YouTube, it's going to pop up on the screen behind me. So feel free to write in your suggestions as well. Okay, so here we are going to start building something with Mindstorms. The cool thing about the competition entry is that they said that you're allowed to build or designed with EV3 as well, which I think it means that they are making the competition open for people who have EV3, and they are willing to sort of try to remodel that model for the new Mindstorms. So what I'm thinking is, instead of balancing it sideways like I have for my model, I'm going to balance it vertically. It's going to be less stable this way because it's much taller, but it's also going to be cooler when it is actually balancing. And what's the goal of today? Well, the goal is to get a robot that can balance first, and then later on we can add some cool stuff to it, right? For example, we got these cannons that new Mindstorms has. Whoops, I just dropped it. These little cannons. If you look at the close-up picture, you can see that we can load up these projectiles and then shoot. The new Mindstorms app is also really cool. You can control via remote control this robot. So potentially this robot can be like a cyber Terminator style robot that can walk around or roll around the table and then shoot targets. And maybe there are other Segway robots as well. And because these projectiles will inflict a lot of force on the robot, it might like knock them over, which will be really, really cool, right? So let's see how we go. So first of all, we need to attach the motors and make sure that they work. When we do prototyping, it's important to, start something simple. Just make sure that, things are going to work at some level before we embark on a massive project, right? And I've been doing like 2 hours of streams today already. I've been teaching a class on Python and with Scratch, so I'm a little bit tired, but that's okay because Lego is fun. Right, just a really simple cable management, and then we're going to use these rubber wheels. Cool thing about Segways is that they're so like, how do I say? They're so unlikely to work. Does that make sense? Which makes it so that when they do work, it's really, really fun and really impressive. The cool thing about the Spike Prime hubs is that they have an inbuilt gyro, which means that you don't have to add all these pieces to get it to work. You just have to make sure that whatever you build is reasonably well balanced along the center. It's symmetrical on both sides, and it's going to be okay. Alright, so this is going to be a very simple Segway robot. So next thing will be to try and connect this up and get working. But once we do get it working, the idea is we're going to attach these cannons, right? So we're going to put these cannons on the side and then have a motor that can fire these cannons in the direction that the robot is facing. So maybe we have another motor on the back or on the top or something. Maybe on the top. Well, I can't put it there because there's a power cable port there. I have to think about how to put the motor so that we can spin maybe a lift arm or something like that, so that it presses onto a button and then it fires the missile ahead. But we'll get to the fun part another day. Today is all about trying to get this thing to stand up. Alright. Let's get this thing charging. Alright, so now let's go into our software. Start a new project. I'm going to code in these coding blocks. And if you haven't seen my balancing robot before, so this is called PID controlling. This is called PID controller, which is which represents proportional, integral, and derivative. And what we are trying to do is create a skeleton of this code, so that all we have to do is tweak the values to keep it working. Okay. So I have this robot. What's the optimal angle to balance is this pitch, 90 degrees. See that? So we're going to build this robot based on that. But before we do that, you're going to create a whole bunch of variables. So we get a derivative. So PID is a very useful controller for a balancing robot, and a lot of people will also use it for things like line followers. All these KP, KI, KD, KH, these are all gain values. I learned this from our friends at Project Persepolis. They're really, really good with robotics. You gotta check out their YouTube channel as well. But yeah, we collaborated on a project called Bike Prime, which was that self-balancing bike model. It's really, really fun to make. Okay, so these are all our variables. Not sure how clear you guys are able to see on your screens, but hopefully it's not too bad. Okay, now when the program starts, what we're going to do is we're going to light up our face. Make sure it works. There you go, smiley face. It kind of looks a bit like Gumby, doesn't it? If you guys know Gumby from the 90s or 80s, it's a cartoon that I grew up with. Yeah. Cool. Alright, let's continue. Let's give it a little bit of wait time. So wait for 3 seconds before we roll into the code. And then we've got to set our target. So remember how our pitch was best when it is at 90, right? So our pitch target is at 90. So power to 3. So this is a multiplier for all our engine motor values. Okay, P. 5. KI 2.1. So all these values are coming from the balancing robot that I built before. That was that flat one from that website. So that's my design. I'm just using its values to start off with because then I won't have to work on these values from scratch, which would take a bit of a time because I was working on that project for a couple of weeks. Okay, IKD. So 4. Like I said, these are the gain values. The gain values are what we need to change if we want to get this robot to balance properly. Set integral to 0. But why am I setting this? So this set integral to 0 part of the code was not actually available on my the bike model. So I added this. I think it was due to some debugging issue. Set movement modes A and B, and then we get into the PID loop. Okay, set error. To roll target minus, so it's pitch target minus pitch. Pitch target. So the idea is that we want to keep this robot towards 90 degrees, and if it tilts one way, it's going to power the engines towards where it's falling. Okay? It's going to power the motor towards where it's falling so that it would roll underneath the center of mass, right? So that, and then eventually it's going to catch up to the fall, and then it's going to start tilting backwards. Then it will have to roll back. And then it's got to do this many times a second in order to stay upright. So let's have a double check of our. So you see how the pitch here is at 90. So when we're tilting forward, we go from 90 down towards 0. But when we tilt backwards, it's also going down to 0. Oh, and we have a huge problem here as well. You see that? So the pitch is at 85. It skips 86, 7, and 8, and 9. It goes straight from 85 to 90. And then when it tilts the other way, there's almost like 10 or 20 degrees where it doesn't measure a discrete value between 85 and negative 85. The thing is that it doesn't even distinguish the difference between leaning forward and backwards. So that's a really major limitation on this robot. So that means we can't actually balance the robot this way. Does that make sense? Because if I was tilting and it was tilting at 60, it doesn't know if it's tilted forward or backwards because it's measuring 60 in both forward and back. Whereas the roll Whoops, it's disconnected. Whereas the roll and the yaw, there is a positive and negative value. So that's a bummer. So that means we need to redesign our robot because our the robot can't balance this way because the system, the hardware won't actually measure a forward lean and a backwards lean and tell us about it. So it looks like we can't continue with this design. But what we will do is we are going to build the robot that I built last time, because we can't end this stream without a balancing robot. That would be silly and boring. So I'm going to build our robot, the one that I designed before, and then what I'll do is I'll do modifications to it so that we meet that competition criteria and make it so that it is still a new design robot. That makes sense? It's a real shame that the robot doesn't detect pitch on the reverse side. That is a major limitation. Okay, so let's use roll again. Whoops. Let's use roll again. So this is the same robot that I built before for YouTube. So if you haven't seen it, definitely check it out. I also explain more about PID in that one. But let's do this now. So I'll need to change all the code basically. Oh well, not all, but just the bits that we talk about roll. We got to talk that talk about pitch. We'll have to talk about roll instead. So here, instead of pitch, let's call it roll time. Roll time, roll angle. Movement mode is now E and A. Okay, let's continue on. And you know what? If I just build this with cannons on it and we can control it remotely, it's going to be awesome. Here we go. Integral. So integral to something plus something multiplied by something. Error. Integral. And then we're going to set derivative. Error minus previous error. Error minus previous error, yep. Previous error is equal to error. And then this is the most important bit, the result. So this is the actual power that gets pumped into the wheels. So it's something plus something plus something. And then for each one there's a multiplication. Error KP. integral KI. Derivative KD. And then here we have a special block. It's an advanced block. So these coding blocks here aren't the only blocks in in Mindstorms. You can actually add more advanced blocks here. So you can add more motors, movement, music, weather management. So the weather one actually checks the internet for some weather forecasts, and also you can attach like the PS4 controller or the Xbox controller as well. So we're going to use movement. Go down to move straight. But instead of going at power, we're going to go at result. Result multiplied by power. Alright. Do I want to repeat this forever? We can do a fall detection later. Alright, let's see how this baby works. Whoop, just disconnected on me. Alright, let's try this. So first of all, I'm going to connect it to Bluetooth. The thing about Spike Prime is that I'm not a huge fan of the connection stability. It always seems to sort of lose connection. But you know, it is a toy, so I mean it's made by a toy company, so sometimes it's not as reliable as I'd like. Alright, let's have a look at this. Oh, let's face it sideways. See that? So this robot is balancing. It seems to lean forward a lot though. Let's tweak this. Roll target 90, that's a problem because the actual value should be around 89. Let's try that. Still not quite there. 88. It's better. Better, but now we got to start adjusting the gain values because we are starting to see that it's tending towards one side, and then the error will grow as it gets pushed. You see how when it's running, I'll show it again. You see how it's sort of okay, but then you see how the error accelerates? So it's sort of fine, but then as soon as I let go, it'll go faster and faster forward until it will fall over, right? And that's obviously not going to be good. So the next step for us is to tweak these values to make it more stable. I know for a fact that these values are going to work perfectly on a carpet because that's what these values were tested on. But for this robot, it's not going to work on table. Whoa! Right. For us is to tweak these values to make it more stable. I know for a fact that these values are going to work. That was interesting. Alright. So my robot just pressed onto something on my computer, I think. There's no second take because this is live. Alright, well, that's it for now. So we got a robot balancing. It is the same robot that I built before, but we are going to have to improve upon it. We're going to try and make it more stable. It's going to balance a bit better. We're going to tweak some values next time. And then we're going to try and upgun it, make it more awesome. And then we can add some flair to it so that we can enter this into that Mindstorms competition. Hope you enjoyed the stream. Leave me a comment below if you have any questions or if you have any feedback. And take care, and I'll see you again next time. Okay?